Welcome to Spring LIB.
All right. So in this problem, we have voltage here, V, and we have two capacitors, C1, C2. So C1, C2, and this is point P. All right, this is point P. Okay. So because this C1, C2, they're cylinder capacitor. So the capacitance for the cylinder capacitor has expression C. I just use the C1 as example, equal to 2 pi epsilon naught L over log E over A, where L is the, so suppose this is the capacitor. Okay, so L is the total length, and B is the outer radius, and A is the inner radius. Okay, so you can simply plug in values given in the problem, and you can find out the value of C1 is 2.53 picofarads. And for C2, it's similarly, you can just utilize the information of its L, B, and A, and you can obtain that C2 equal to 3.61 picofarads. And the combination of C1, C2, as you can see that they are connected in series. So the combination of them will be 1 over C12 equal to 1 over C1 plus 1 over C2, right? So you can solve for C12 equal to C1, C2 over C1 plus C2. So the value is 1.49 picofarads, yes. And we also know the voltage across C1, C2, it's 10 volts. So we can solve for the Q, the charge stored in the two capacitors. So it's simply Q equal to V times C12, 14.9 pico coulomb. Okay. And then the separation of the second one, the separation of the C2 is increased. So we can obtain a new C2, so which is labeled by C2 prime. So just utilize the number in the problem. You can find the C2 prime is 2.17 picofarads. So the expression is the same. Just utilize this expression. Okay. So C2 prime is over here, and we can find out the new combined capacitance C12 prime equal to C1 C2 prime over C1 plus C2 prime. So the value is 1.17 picofarads. So because the voltage across C1 C2 prime does not change, so basically Q prime simply equal to V times C12 prime equal 11.7 picocoulombs. Okay, so the change of the charge, delta Q equal to Q. So we just use the absolute value here. So Q minus Q prime, which equal to 3.2 picocoulombs. Okay. So we want to know how many electrons moves across the point P, because we already know the charge change. And as you can see, when after we increase the separation, we know that the charge across the charge stored in C1 and C2 are actually lower. So it means that there are several charges come back to the battery. And each electron carry the voltage 1.6 times 10 to the negative 19 coulombs. So wait, there's not much room for me. I put it here. So N in this case simply equal to delta Q over E. So this will give you 2 times 10 to the 9th So there are actually 2 times 10 to the 9th electrons moving across point P. And because you know the electron carry negative charge, so basically it means that the electron is moving to the opposite direction. So the electron is moving to the right. So you can conclude that the electron is moving away from the battery to the capacitors, and the number of the electrons is 2 times 10 to the 9th. Okay.